In this video, we're going to look at radioactive half-lives. So the half-life of thorium-229 is 7,340 years. And we want to know how long it'll take a sample of thorium to decay to 20% of its original amount. Okay, so for growth and decay, the amount of substance is equal to A naught times e to the kt, where k is that growth or decay rate. Well, right here we have a half-life. So because it's a half-life, A is equal to 1/2 of A naught. And we can jump straight to this formulation. 1/2 is equal to e to the kt. So our next question is, do we know t? We certainly do. It's 7,340 years. So 1/2 is equal to e to the 7340k, right? Substituting in for t. So the natural log of 1/2 is equal to 7,340k. So what is k? The natural log, or I'll write it like this, the natural log of 1/2 divided by 7,340. So let's figure out what k is using our calculator. I'm going to take the natural log of 1/2. I'm going to divide that by 7,340. And we've got this nice little value. I'm going to store that as a variable. This is negative 9.44 times 10 to the -5th. I'm going to double check that. Yeah, 10 to the -5th, or negative 0.123494. That's k. Okay, and we're looking for the how long it'll take to decay to 20%. So A needs to be 20%, 0.2 A naught, right? 20% is equal to A naught e to the kt. And I'm going to be lazy and just leave that as k, because I know what k is right here. I'm just going to plug it in the calculator. There's no reason for me to leave it right here. Okay, but take a look. It's 0.2 A naught is equal to A naught e to the kt. These will reduce out. So we'll get 0.2 is equal to e to the kt. And remember, we are solving for t. We're looking for t. So I'm going to take a natural log of both sides. I'm going to take the natural log of 0.2, and that's going to be equal to just plain old kt. And I'm looking for t. So t is going to be equal to 1 over k, natural log of 0.2. And remember, we have k stored in our calculator. So I'm going to pull up my calculator. I'm going to take the natural log of 0.2, and then I'm going to divide it by that value that I found, which I stored as x. And I will get 17,043 years. T is equal to 17,043 years. And in here, what was important was we had this formulation to find k, and then I had this same similar formulation to find t. Great. And we started both of them with this exponential model. A is equal to A naught e to the kt. Awesome. Remember this model. Next time we'll do more.